the heap sort algorithm? First, I will try to describe this algorithm in simple and plain words. Then I will show you the actual algorithm. And after that, I will take a small example and try to dry run this algorithm on this example. What we do in the heap sort algorithm, we first build a max heap out of the given array. We are given an array for sorting purpose. This is the array which has elements from 1 to n. And the very first activity which we will do for this array, we simply convert this array into max heap. We are going to use the max heap for this purpose. We repeatedly extract maximum item from the heap. And where is the maximum item? It is on the root of the heap. And if we talk in terms of array, it is located at location number 1, A1 location. We simply extract this element from the heap and place this element at the end of the array. Simply extract the element and place this element at the end of the array. And if we extract the element from the heap, there is kind of a hole created on the top of the heap. And how to fill this hole? We simply swap the first and the last elements of the heap, and we simply just fill this hole by exchanging the first and last element of the array or the heap. And if we simply replace first element with the last element, the heap order property will be violated. And how to maintain the heap order property? For this purpose, we will call a function with the name heapify. So we will use another procedure here, the heapify procedure. And what this procedure will do, it will simply convert the tree again into heap, but we will create the heap for n minus 1 elements now. We have created the heap starting from the n elements. Now we will create the heap now again for the n minus 1 elements. Now this is a simple algorithm. Now I will explain this algorithm in proper format. Here, the name of the algorithm, you can observe that is heap sort. It has two arguments, an array which we want to sort, and after that we have the size of the array. N is the size of the array. If the array has 1000 elements, it means that n is equal to 1000. A is the array which we want to sort. So what we will do in the first step, we call a function with the name build heap and pass the same array A and its size to this function. And what this function will do, it simply convert a array into heap by using its activities or functionalities. It will convert the array into heap. After that, we have used a variable with the name m, and it is initialized with the value of n. So we simply perform m is equal to n here. It means that if the value of n is 1000, the value of m is also now equal to 1000. So here we have used a loop. This is a decrement loop, and you can observe that we have condition here, m greater than equal to 2. It means that this loop will keep on executing from end to 2, not to 1. We are actually executing this loop 1 minus n minus 1. You can simply say if n is the size of the array, then this loop will be executed n minus 1 times. So what we are doing here, just carefully look at, we are swapping the first element of the array with the last element of the array. You have also done this type of exercise in doing the analysis of the algorithm. We are simply exchanging, swapping first element with the last element of the array. The first element of the array is the root of the heap, and the last element is actually exchanged with the root. And if we perform this activity, we know that the tree will no more be a heap. And just to convert this tree into heap again, we will have to call a function with the name heapify. Okay, in statement number 6, you can find a function with the name heapify, and this heapify is now called with m elements. So this is very interesting. If your array consists of 10 elements, the next time you are calling heapify with 9 elements. So you only want to convert the tree into heap for one less elements. This activity is actually keep on repeating, and at the end you will find this whole array will be sorted. Uh, Now I have considered this array for passing to the heap sort algorithm. You can find this array is not sorted, and I want to sort this array, and the argument of the function are a7. Now n is equal to 7, and this is array A which we want to sort, which consists of 7 elements, and we will call the build heap function. In the first line of the algorithm, we will call the build heap function, and in the second line, m is equal to 7. So the same value m will have the same value as the n has. The both are equal to 7 in this situation. So what the build heap will function will do, it will simply convert this array into heap. Now you can visually find the heap of this array. This is in tree form, this is the logical form, this is the actual form. This is the actual saved heap in the form of array. Same 87 is at location number 1, and then 57, 50, 44, 12, 15, level by level values are stored inside the array. This is the tree format is actually the visual format. Actual format is one-dimensional array, which is kind of the heap version of the 7-element array which we have here in this situation. So after that, we will have to execute this loop. This loop will be executed greater than equal to 2 starting from 7. It means that this loop is going to be executed 6 times, one less than the total number of elements. This loop will be executed 6 times. I will also ask a question at the end of the lecture why we have to execute this loop n-1 times. Why not exactly equal to n times? So what we are doing in this loop, we are swapping a1 with am. So value of m is equal to 7. So we are swapping element 1 with element 7. So from tree, you can observe that we have swapped element 87. Here we have previously 87, and here we have previously 23. You can observe from the array we have swapped the first element with the location number 7 element. From tree, you can observe that now we have 23 on the top of the tree and 87 at the end of the tree. But if you observe that after performing this exchange or swapping, this is not a heap anymore because we have 23 in the top of the tree here, but 23 is smaller than 57 and 44. This is not a heap. Just to make it a heap again, we have called the heapify function. and heapify is called with same array but for only 6 elements. Now we want to convert this tree into heap, but only for this portion of the tree. Okay, this heapify function, what it will do, it simply convert or heapify or reheap the tree which has some kind of violation inside it, and it simply convert this tree into heap again. So you can observe that this has converted into heap again and again. Now if you observe this loop again, now the value of m is equal to 6 in the second iteration. In the first iteration the value was 7, now the value is equal to 6, and we are swapping the element number 1 with element number 6. So it means that we are swapping here. If you are observe, we are swapping 19 with 57. These two elements are actually being swapped in the next iteration, and if you now observe that we have 19 in the first location and 57 in the second last location. You can observe this line here. The elements are being sorted at the end. We have first filled the last location, now we have filled the second last location, and this process is repeated again. We will have to heapify this tree now, and previously it was not heap. This 5 element tree is not heap anymore. Just to heapify it, converting it into heap again, we have to call this heapify function, and it will convert this tree into heap now, which has now 5 elements, and we just repeat the process again. Now the value of m is equal to 5. Element number 1 and 5 will be swapped, and we have called the heapify function for 4 elements now. And again this activity is being performed, and at the end when we have m is equal to 2, okay, we only have 2 elements in the tree, and we simply swap these elements, 12 with 15, and they are simply swapped, and after that the value of m will become 1, and this condition will return false. It means that this loop is not going to be executed now, it will be terminated. And if you simply look at your array, it is sorted already in a sorted form. This is actually is a ascending order sort. You can observe that your array is now sorted. Okay, my question at the start of this discussion was that why we have used this condition, and you can observe that we only have one element in the array, and there is no need for swapping just for the one element. If we only have one element in the tree, there is no need for swapping. Then you can control your loop one less iteration, and that is why we have provided n minus 1 the ending condition for this loop. So simple idea of this algorithm, whenever we receive an array for sorting, we simply convert this array into a max heap, and then we execute a decrement loop, and we simply swap first element with the last element, and then again convert the tree into heap, but for one less element, n minus 1 element, we will construct a tree for one less element every time in the iteration of the loop. Okay,